Alright, this is PreCalc Chapter 7. This is the partner test. Number 1. Number 1 wants you to describe the transformations that change the graph of f of t equals cosine t to the given graph that's shown here. So, your A. This A value out front is your amplitude. So that's a vertical compression by 1/3. That changes your vertical height or distance from the x on your graph. Your B value, you're given a 2. That means that you have a horizontal compression by 1/2. Remember that when you write it, it switches. So instead of a 2, you have a 1/2 compression. Your C value, that's your phase shift. For a cosine, we have to find our phase shift, so we're going to pull out that B value. So we're going to pull out that 2, and that's times t minus, it's going to be pi over 12 when you pull that 2 out. So now your C value is that pi over 12. So you are shifting pi over 12, and it's a minus, so that means we're going to the right. So we have a phase shift of pi over 12 to the right. And then your D value is this minus 5. So we have a vertical shift down 5. Is everybody good with that? Number 2, you're taking the information that's provided and you're writing an equation for it. So we're told that the sine function is stretched vertically by a factor of 4. That's going to be our A value. It has a period of pi over 6. So that pi over 6, we're going to find our B value. So our period, we're going to set equal for the sine function is equal to 2 pi divided by the B value. So we're going to cross multiply and solve for B. So we're going to get pi B equals 12 pi. Your pi's will cancel out, and you'll get B equals 12. So now you have your B value. We're told that it's reflected over the x-axis, so that's going to make our A value negative. And then we have a phase shift of pi over 3. That's our C value, and it's to the left, so that's telling us that we're going to be adding that C value. So when we actually write this all out, our A value is 4. We're writing it for the sine function. Our B value is 12 times x, and then we're adding that phase shift of pi over 3 because it's to the left. And again, we have that reflected over the x-axis, so it's a negative 4. And there is no vertical shift up or down, so it's plus 0. Number 3, the function g of t equals cosine t is an even or an odd function. So you had to choose whether it was an even or an odd function. Cosine is an even function. Remember that an even function has symmetry about the y-axis. So if we folded our graph in half at the y-axis, it'll be the same on the left and on the right. If it were odd, it would have origin symmetry. So,
explain that one.
why it's even?
Yeah.
It's even because it's symmetric about the y-axis. So if you look at your cosine curve, if you split it right at the y-axis, it's the same on the left-hand side as it is on the right-hand side. Okay? Odd is symmetric about the origin. So that would be your sine function or your tangent function. That you're going to have a point that both your x and your y are both positive, and you'll also have a point that your x and y are both negative for the same spots. So it's kind of like they're on opposite sides of the axis. Okay? Number 4 wants us to find the y-axis or the y-intercept of the graph of -4 sine t plus 2. This one you shouldn't have to graph, but I did provide a graph in case you need to actually see where it is. So what this is telling you, for sine, we know that we normally start at the origin because we're on, and then we're above, on, below, on. So we normally start on the y-axis at 0, 0. But we have a vertical shift up 2. So we're actually starting right there at that up 2 spot. So our sine graph will start here. So that's our y-intercept. And that point is 0, 2. We haven't gone anywhere on the x-axis, but we've gone up 2 on the y. Number 5 wants us to name the domain and the range of 3 cosine t minus 6. Again, this one you shouldn't have to graph, but if you need to visualize it, you're provided the graph. So the domain, remember that the domain for cosine and sine is always all real numbers. This wants you to write it in interval notation, so it technically should be -infinity to infinity. I did accept if you wrote all real numbers though. Then it wants the yes.
Is that okay tomorrow too?
Yes. It then wants the range. So remember that the range for sine and cosine goes from your minimum value to your maximum value. So if we were looking at the normal cosine curve, your maximum value is at 1, your minimum value is at -1. So we're going to take that information and we're going to plug those values in for cosine t to find our new minimum and maximum value. So if we take 3 times 1 minus 6, that's going to give us our new maximum value because 1 was our old maximum value. We're going to get -3. Then to find our minimum value, we're going to take 3 times -1 minus 6 and get -9. So those are our new minimum and maximum. So when we write out our range, it should be bracket, your minimum value, so -9, comma, your maximum value, -3, and another bracket. On the top of the next page, you're asked to find, for negative cosine t, what interval is the function increasing from -2 pi to 2 pi? And I gave you a hint that you should graph it. So if you graph the negative cosine t graph, you're going to break up your graph. So this is 2 pi. So that means that that's pi. And then the same thing in the opposite direction. -2 pi and pi, -pi. And remember your pattern. For cosine, you're above, on, below, on, above. This, however, is negative cosine. So rather than starting above, we're starting below.
As above, so below.
So we're below, on, above, on, below. And then the same thing in the opposite direction. I just realized that I labeled this wrong. That should be -pi. So now your cosine curve should look a little nicer than mine, but we'll go with it. So your cosine curve should look like that. So now what the question is asking is for the interval in which the function is increasing. So your function, your cosine function is increasing here, and it's increasing here. in those two sections. And you need to write your answer in interval notation. So remember, when you have an increasing or a decreasing area, your endpoints are not included. So that means we're going to use parentheses. So we have parentheses, negative 2 pi is where we start here, and it ends at negative pi. And then union, our second portion, starts at 0 and goes to pi. So that is the area that the interval, or that the function is increasing. So you have two sections. Now, 7 through 9 are where most people lost points. We need to find all the values for which the given statement is true. So number 7, we're looking for all of the t values for sine t equal to negative 3 pi, or negative root 3 over 2. So we want to go back to thinking about our unit circle and our triangles. That's how we're going to solve this. So we're going to ignore the negative for right now. We'll draw our axes in. And if we draw our angle, so this is our theta or our t value. And when we have sine, we know that this is opposite over hypotenuse. So we have root 3 over the 2. So immediately when we have a root 3 in our triangle, we should automatically be thinking that it's a 30, 60, 90 triangle. And that angle, when root 3 is over 2, is actually a 60-degree angle, but we're thinking in radians now, so it's a pi over 3. So now is when we're going to look at that negative. That negative is going to tell us which quadrant we're looking at, where that value is going to be negative. So an easy way to remember that is using ASTC, TC. And like an acronym or a way to remember that is all students take calculus. That tells you the quadrants. And what this tells you is that in quadrant 1, all of your trig functions are positive. In quadrant 2, only sine is positive. In quadrant 3, tangent is positive. And then in quadrant 4, cosine is positive. So we're looking for where sine is negative. Well, sine is positive in 1 and 2, so it must be negative in 3 and 4. So we're looking at quadrants 3 and 4 for this problem. We need to find those 60-degree angles in those quadrants. So in quadrant 3, our angle is 4 pi over 3. And in quadrant 4, our angle is 5 pi over 3. So those are the two angles where sine is going to equal negative root 3 over 2. But we want to find all the values for where that's true. So now we're going to add and subtract multiples of 2 pi. So that's going around your unit circle multiple times. So every time that you come back to that angle, there's going to be a value that equals root 3 over 2. Yes?
Okay, so what is it, 5 pi over 3?
That's how you break up the unit circle. So if we broke it up,
So we got that pi.
so you'd be breaking each section into 3s. So that's a third, that's a third. That's a third, that's a third. So you have pi over 3, 2 pi over 3, 3 pi over, or, sorry. So you have pi over 3,
2 pi over 3.
2 pi over 3,
3 over
3 over 3 would be
3.
here,
Yeah.
4 over 3, and that's 5 over 3. Here, it's weird how you have to look at it here, but basically you're breaking it into thirds.
So is the last angle in relation to the axis?
Because this would be like going back to 60,
Okay,
so.
so I'd just be flipping it over.
Mhm. So
it'd be-
it's just breaking up your
So that's
units.
300 is what that is, like if I were to, okay.
Yeah, it's just how you break up your unit circle. So then the same thing for the 5 pi over 3 is 2k pi. So we're adding and subtracting multiples of the unit circle. For number 8, we have cosine t equals 0. So this is where we're looking at where cosine equals 0. So if we go back to our previous example, we can see that cosine equals 0 whenever it hits the x-axis. And cosine hits the x-axis at pi over 2, which remember is our y-axis here. So it hits at pi over 2, and then it's going to hit again at 3 pi over 2, which is down here. So for this one, for all values, we're looking at the multiples of pi over 2. So pi over 2 plus or minus 2k pi. And then we're looking at the multiple of 3 pi over 2 plus or minus 2k pi.
Wait, so how did you get that? You went from just how what it is on the unit circle?
So that's where you're looking at where cosine of t equals 0. So your cosine equals 0 when it hits the x-axis, and that's at pi over 2 and 3 pi over 2. Okay?
Mean y-axis.
Yeah.
Well, when you
No,
actually graph it, it's hitting the x-axis. So that's where your zeros are.
Oh,
It's 0 on the
okay.
x-axis because it's not moving left or right, but it's moved 1 unit up and down y.
Okay.
Also thinking about this with your unit circle, remember that cosine is y over your radius. So whenever your y is 0, you're gonna get a 0. So
Oh.
that's how you got those two. Either way, you can think about it. And then number 9 is tangent of t equals 1. So again, you want to draw your axis, you want to draw your angle. And tangent we know is opposite over adjacent, so that's 1 over 1. So automatically you should be thinking that this is a 45-degree angle or a pi over 4 angle. That was our 45-degree angle in radians. So again, we want to look where tangent is positive. We know it's positive in the first quadrant and in the third quadrant. So this is our first quadrant radian, so pi over 4. And then we need our third quadrant one, which is going to be 5 pi
Yeah, right.
over 4. And again, you want to add multiples of that. Add and subtract multiples of 2 pi. Now the tangent one actually can be rewritten as multiples using pi, but I will accept it like this, so that they all are consistent. So for all of these, we're adding and subtracting 2k pi. Does anybody have any questions about those? No? Okay. 10 and 11, you need to write the equation of the functions that are graphed. So for number 10, looking at this, we know that it starts at the y-axis and it goes down, and then it's going down. So we automatically should be thinking that this is some sort of sine function. So we know we have a sine function. And then we see that we have
There's like I'm trying to
a
smash.
stretch, a vertical stretch of 1, 2, 3. So we have an amplitude change of 3. All of our sine curve parts are going in the same direction, where they would normally continue up like that. These are all going in the same direction, so we automatically should think that this is an absolute value. But normally the absolute value would make everything positive. In this case, they're all negative, so it's a reflection. So you have that -3 now, absolute value of sine. And then we have a shift up 2, so +2. And these two are going to be without any of your phase shifts or your period changes. So these are just going to be your regular sine, cosine, tangent, cotangent, that kind of stuff. Number 11. 11, it might be helpful to draw in the sine or cosine curve, whichever it turns out to be. So you know that up here at the peaks, you're going to have your curve hit it like that, and at the asymptotes, you're crossing the x-axis. So that would be your curve in between. So whichever curve you end up deciding it is, you just take the reciprocal of that curve. So in this case, we're starting, if we start at the origin, we've got a sine curve. So that means that this is going to be a cosecant, because cosecant is the reciprocal of sine. And looking at this, we have an amplitude change of 1, 2, 3. There's no vertical shift. And there's no other changes, so it's just 3 cosecant of x. Any questions about those two? All right, the next page is all graphing. The first 4, 12 through 15, are just your regular ones. There's no phase shifts, there's no period changes. These are just your regular graphs. So the first one that we're given is -2 tangent of t plus 1. And you need to graph between -2 pi and 2 pi. If you graphed past that, I didn't mark you down. If you didn't graph the whole section, you got marked down. So please make sure that you're graphing the entire area that it wants you to graph. So we have a -2 tangent, and we're up 1. That's what that +1 is giving us. So we have that vertical shift up 1. So we have a new x-axis. Our first asymptote for tangent, remember, is at pi over 2. And then, again, the pattern for asymptotes is every other. So we had pi over 2, skip 1, negative pi over 2. And the same thing in both directions. So you should have those 4 asymptotes. And then for your tangent curve, you know that it crosses at your x-axis. So in this case, we're crossing at our new x-axis. And we have a -2, so this is actually going to reflect it over, and we're going to be up 2. So we're going to be up 2 and down 2.
Shut up! That's not on screen.
Sadia, go tame those heathens out there.
Hello, and going back to wherever they came from.
Okay, and then, so you should get a graph
Like that.
that looks like this. And again, make sure that you're graphing -2 pi to 2 pi. So for your endpoints at the -2 pi and the 2 pi, on the left-hand side, you're going to have the part that comes down and follows the asymptote. On the right-hand side, you're going to have the part that comes up and follows the asymptote. So that is technically the graph from negative 2 pi to 2 pi. Again,
Technically.
if you drew more, I didn't mark you down, but if you didn't draw at least that, you got points taken off.
Oh, I know.
So number 13 is a cosecant graph.
So you do want us to draw it in half one?
Yes.
So they each go a different way on 12.
Yes.
Okay.
You're following the asymptote, so you're just following the same pattern that you did already. For number 13, we have a vertical shift up 2. So our x-axis is up that 2.
These days I'm going to purposely tilt the camera down to get the person.
And then remember that we have asymptotes for cosecant. And if you don't remember where the asymptotes start, remember your pattern for sine. So if we start at the origin, remember we would normally be on, above, on, below. But in this case we have a negative 2 out front. So we're going to be on, below. So on, and then we're going to be below, and we have to shift that 2. Now we're on again, and then we're above 2, on, and then that's that side, and then doing the other side. So you should have, this would be your normal sine curve for this case, but we want the cosecant. So anytime that you have a dot that hits your x-axis, that's where an asymptote is. So at all of these zeros, we have an asymptote. And then if you have a point that's above your x-axis, those are going to be the parabolas that point up. And then if you have a point below the x-axis, those are going to be the parabolas that point down. So from negative 2 pi to 2 pi for this graph should look like that. Number 14 is 3 times the absolute value of sine minus 2. So we have a vertical shift down 2. And then we're looking at the absolute value of sine, so they're all going to be above our x-axis rather than going below. So if we start at the origin here, we're on, and then we're above, and we're up 3 because we have an amplitude change of 3. So we're here, and then we would be back on, and then normally we would go below, but because this is an absolute value, we're back above.
Wait, why aren't we on in the first place?
Where what?
Why aren't we?
You start
Oh,
on,
okay. I didn't
above, on, and then rather than going below, we're going back above, and then we're back on. And then the same thing in the opposite direction again. So then this sine curve is going to look like that. Are there any questions on 14?
Feeling hot on this page.
Yeah. And then the back page said, oh.
And then 15.
Where's the edge?
Partner tests weren't great, so you might want to pay attention.
I'm paying attention this way.
Yeah.
So for 15, we have -3 cosine t minus 2. So we have a vertical shift down 2. And then we have our cosine curve, but it's going to be the reflection of our cosine curve. So normally we would start above, but in this case we're going to start below.
As opposed to-
And we're going to start below 3 because we have that amplitude change. So we're starting below, on, above 3, so 1, 2, 3, on, and then below. And then again, same thing in the opposite direction. So you should get a cosine curve that looks like this. So your cosine curve should look like that. And then number 16 now is where we bring in the phase shifts and the period changes. And this one is asking you to graph one full period of the function that's given there. So your amplitude is your A value, so that's that 3. Your period is going to change by your B value. In this case, it's that half. So remember for sine and cosine that it's 2 pi divided by your B value, so in this case 1/2. So that's going to be like 2 pi times 2, which is going to be 4 pi. Remember that your increments are taking this new period value that you got and dividing by 4. So you're going to have 4 pi divided by 4, which is just going to give you pi. Your phase shift, remember for sine and cosine, we need to pull out that B value. So we have 1/2 times t plus 2 pi when we pull out that B value out of the parentheses. So this gives us our phase shift. And remember, this is a positive, so this is going to be 2 pi to the left.
Ooh.
So our actual start value is at -2 pi, is our actual start. If we're going 2 pi to the left. And then our vertical shift is up 2. Yes?
So if like, since sine and cosine is 2 pi over b, what is it for tangent?
For tangent and cotangent, it's pi divided by the B value.
It's like half.
It's the original period divided by the B value. So our original period for sine and cosine was 2 pi. Our original period for tangent and cotangent was pi. So now to draw this graph, we're going to draw in our vertical shift, which is up 2. So we have that new x-axis at 2. We're going to start labeling at -2 pi, because that's where we're starting. That's our phase shift. And then we're going to count using our increments, which are pi. So we have, going to the right, we have -pi, 0, pi, and then 2 pi. You could also go to the left.
If you
So
go
now
to,
remembering, yes.
if you go to the left and you start at 0, would it go to 4  pi?
If you're
Or
going to the
right
left,
here.
you would be starting at your -2 pi. So you'd go -3 pi, -4 pi, -5 pi, -6 pi.
Okay.
Okay? So remembering our pattern for cosine, we are above, and we're above 3 because we have that amplitude change. So we're above, then we're on, then we're below 3, then we're back on, and then we're back above 3. And this only asked us to graph 1 full period, so that's 1 full period. So that is your cosine curve for this problem. On to the last page. This graph wants us to graph 2 full periods of the tangent function that's given. Yes.
When they say like, graph 1 full period, 2 full periods, are you ever gonna mark down some of the
No, if you do more than what's there, that's fine. But you're only required to do what's listed. So, for the tangent function, our steepness again is given by our a value. So there's like an imaginary 1 here. So our steepness is 1. Our period is still that b value, but now it's pi divided by the b value. So we have pi divided by 4. Our increments are that period divided by 2 this time for tangent and cotangent. So we're going to have pi over 4 divided by 2, which is like pi over 4 multiplied by a half, which is going to give you pi over 8. Your vertical shift, we have a plus 4, so we're up 4. And then we have to find for tangent and cotangent, we have to find that first asymptote. So when you find the first asymptote, you're taking what's given in the parentheses, and for tangent you're setting it equal to pi over 2. For cotangent you set it equal to 0. So this one is a tangent. So we have 4t plus pi over 6 equals pi over 2. And now we're going to solve for t. So we're going to have 4t equals pi over 2 minus pi over 6. You want to get a common denominator so you can combine those. You're going to get 4t equals 2 pi over 6. And then you're going to want to divide by 4. So you're going to get t equals 2 pi divided by 24, which reduces to pi over 12. So we find that our first asymptote is at pi over 12. Like with our previous examples though, we want to get our increments and our asymptote in the same language, if you will, or the same denominator so that we can find them when we're labeling our graph. So in this case, we're going to have to change how we're using our increments, and we have to change our asymptote so that we can get a common denominator for both. So for the increments, we're going to get both of these over 24. So for the increments, we're going to multiply the top and the bottom by 3. So we're going to get 3 pi over 24, and that's how we're going to count now. And then for our asymptote, we're going to multiply the top and the bottom by 2. So we're going to get 2 pi over 24. And that is our start. That's where our first asymptote is going to be. Now for tangent and cotangent, remember that you don't have to worry about whether you're going to the left or the right. When you solve for t and you find that first asymptote, that tells you exactly where you have to start. So we're starting at 2 pi over 24 in our graph. So we have 2 pi over 24. And remember, our increments changed. We're counting by 3s now. So we're going to have 5 pi over 24, 8 pi over 24, 11 pi over 24, and 14 pi over 24. So we know that we're starting at 2 pi over 24. That's where our first asymptote is. And then again, the pattern is still the same, that you skip 1, and then you have the next asymptote. So there are your asymptotes. we have that vertical shift up 4. So we have a new x-axis up 4. And then this is the tangent function, so we just use our pattern for tangent, that it crosses the x-axis right in the middle. We only had a steepness of 1. So our tangent function is going to look like this. And you have to do 2 full periods, so that's 2 full periods of that tangent function.
Thanks.
Any questions about that one?
How do you get the increments again? For like, why'd you multiply by 3 over 3?
We multiplied by 3 over 3 because we wanted to get our increments and our asymptote so that they were in the same, like, so that they had the same denominator, so
Okay.
that we could find it when we were labeling our graph.
Okay.
Okay? And then finally 18, you need to graph 1 full period of the function that's given here. In this case, it's a cosecant. So our amplitude again is our A value. So that's 2. Our period, we're going to take that B value. And it's 2 pi divided by that B value. So 2 pi divided by 2, which gives us pi. Our increments are that period divided by 4. So we end up with pi over 4. To find our phase shift, we need to pull that B value out. So it's 2 times t minus pi over 2. So our phase shift is pi over 2. And it's a minus. So it's pi over 2 to the right. And again, we want to get that phase shift in the same, we want to have the same denominator as we do in our increments. So we're going to multiply by 2 over 2. So we're actually going to start at 2 pi over 4. That's our actual start value, or our actual starting point. And then we have and then for this one we don't have a vertical shift. There's nothing added on to our function. So again, graphing this, there's no vertical shift. We're starting at 2 pi over 4. And we're counting in increments of pi over 4. So we have 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and then 6 pi over 4. And this is only asking for 1 full period. So we're looking at cosecant, so that's the reciprocal of sine. So if it helps to write in the points for sine first, go ahead and do that. So for our pattern for sine is on, above, on, below. But again, this is a reflection. We have a negative out front there. So we're going to start on, go below. We have that vertical stretch of 2. On, above, on. So that's 1 full period. And remember that anytime you have a 0 or your sine graph crosses the x-axis, those are your asymptotes for cosecant. So those are your asymptotes. The point that's above the x-axis is your parabola that points up. Your point below the x-axis is your parabola that points down. So that is 1 full period of that cosecant graph. Any questions on that one? And then our last question is using different trig functions to write equations for the same graph. So for this one, my suggestion, if you're given a cosecant or a secant, depending on where you're starting, draw in the curve, like the original curve, that would be the reciprocal. So draw in, starting at A, you know your curve is going to go like that. And that'll help you. So you can decide if it's sine or cosine at those points, and then just switch it for the reciprocal function. So then the next thing that we need to do is we need to determine what our increments are here, because we're given this pi over 4, but it's broken down further than that. So it's broken down into thirds. So we need to take pi over 4 and multiply by a third. That's like dividing by 3. So you're going to get pi over 12 as your increments. So using those increments, we're going to find what 1 full period of this graph is. So if we look at our curve that we drew in, 1 full period starts at our A value and goes here. So we're just going to count. We have 1 pi over 12, 2 pi over 12, 3, 4, 5, 6, 7, 8. So we have a period of 8 pi over 12. And what we're going to do with that period is we're going to find our B value. So we're going to set that equal to 2 pi over B. Remember, that's how we found our period, was by setting 2 pi over our B value. So now we're going to solve for our B value. So you're going to get 8 pi B equals 24 pi. The pi's cancel. Dividing by 8, you get B equals 3. So our B value is 3. So now with all this information, we're going to write our equations. So A is this point here. If we started at this point, looking at our curve that we drew in, that would be a sine function. So the reciprocal of the sine function is cosecant. So A is going to be a cosecant. Our amplitude change, we're going up 2. So we actually have that vertical stretch up 2. We just found our B value to be 3. And that's going to be times x. And we're starting back here at negative pi over 12, 2 pi over 12, negative 3 pi over 12. So that's like adding, that would be, when you go to the left, remember that you add 3 pi over 12, or you could also write it as pi over 4. This could also be
Why did you convert it in the
pi
first
over 4.
place?
For what?
You had the pi over 4, like how did you?
Because we have different increments
Okay.
here.
No, but like where did you pull the 12 from?
Oh, up here. We have, they give us this pi over 4,
Yeah.
but it's broken down by 3 in between there.
Weren't you the one that went, nah?
No, that was earlier at something else.
No,
But
that
you-
was a couple days ago. You went, when I was teaching, you break it up into 3.
Oh, I knew that, no.
That's what this is. Same thing.
Okay.
And then,
Had a lapse then.
and then our equation for B. For B, we're starting here. If we look at that curve that I drew in, if we start at B, it would be a cosine, so that makes it a secant. And our amplitude is the same. Our B value is the same. The only thing we change is where we started. We're starting at pi over 12. Go ahead and stop it there.